Hi, my name is Nit Patel and I am representing Carrier Auto. Carrier Auto is trying to design automation to support commercial HVAC chiller products. Our team lead is Garrett Harp, and our members include Dylan Appleyard, Christian Sandoval-Mata, Rami Shami, and myself. Our faculty mentor is Dr. Wang, our grading instructor is Dr. Nettles, and our industry mentors are Mr. Dennis, Mr. Van Voorhees, and Ms. Ozor. A quick project overview can be stated as this. Carrier Charlotte Arm is responsible for building AC systems, and the senior design team is responsible for creating and developing programs that can help expedite design work on these products. Specifically, they want us to create 5 programs. The first program is a copper tube assembly program that automatically creates drawings for copper tube assemblies. The next program is for the same functionality, except it works for sheet metal components. The Legacy Component Approach program is responsible for databasing important references and dimensions of parts. The ECN Audit program is responsible for automatically checking engineering change notices for any errors and notifying the user. And finally, the Component Replacement program is responsible for automatically replacing components in parent assemblies within Creo as they are run through the program. So I'm going to talk a little bit more in detail about the copper tube assembly program, which we have been working on this semester. The copper tube assembly drawing program creates drawing files of assemblies that are put into the program. It creates these drawings based on the standards input by the user at the start of the program. Additionally, what this does is it creates the drawing views, relevant dimensions, insertion depths, weld callouts, general notes, bill of materials, along with filling out the important parameters within the title block. After the files are successfully run through the program, an output log is generated, which contains information regarding what files passed and what files may have failed, along with the reason for failure. Figure 1 in the top left corner is an example of a copper tube assembly drawing that was generated by the program. Below it is an output log generated for a batch of assemblies that were run through the program. And next to it there is a flow map describing the logic that governs the way our program works. The sheet metal drawing program is very similar to the copper tube assembly drawing program in that it creates drawing files for sheet metal components that are put into the program. It does this by placing down the views and dimensioning these views based on the type of dimensioning, whether linear or ordinate, selected by the user at the start of the program. Additionally, it allows users to remove any extra dimensions they may not need in this file. Our plan for this semester was to deliver the copper tube and the sheet metal drawing programs. Next semester, we plan on delivering the Legacy Component Approach, ECN Audit, and Component Replacement programs. Our expected deliverables are the programs, along with the flow maps, video demonstrations, and standard of works.